Welcome students. Now in this video we are going to see the classifications of NC machines. So see here, basically these NC machine tools are get classified based on three criteria. One is that is the control system. Based on the control system, first thing I can say, based on or based upon the control system. In that we are having number one, point to point control system. Then we are having straight line control system. Then third we are having contour control system, isn't it? In B we are having the classification based upon the feedback system. The feedback system that we know very well, that is open loop system, and second is closed loop system, and third classification we are having, that is based upon the axis controlled, that we are having, say, two-dimensional, then we are having three-dimensional, we are having 4D, we are having 2.5D, like based on the axis control system we are having up to 11D we are having actually. Okay, so this is the classification of numerical control system. Now let us discuss this classification one by one. Okay, if I take this first, that is the classification based upon the control system. So see here, in point-to-point control system, this is also known as position control system. Position control system. So here, in the tool movement, so here the endpoint, suppose my tool was here, okay, and at an instant of time, say my tool is here, okay, so this is the start point, this is the end point. Okay, now see here, in point to point or position control system, the movement of the tool, only the end points are important. That is, whatever the path traveled by the tool is not important. So suppose how it is come here from, say, point 1 to point 2, whether it come like this or like this, so no issue how it comes, but path is not important, end points are important. For say example, we are having drilling operation, reaming operation, isn't it? We are having sheet metal operations, punching, blanking, isn't it? We are having spot welding. So where the length followed by the tool is not important, but the end positions are important. This is known as point to point or position control system, and where there is only necessity of the only one axis simultaneous movement is enough here. Only one axis simultaneous or directly one axis movement is important or possible. Movement is possible. So this is the point to point control system. Please remember, in point to point, only in the movement of the tool, the starting and ending points are important. Whatever the path followed by the tool is not important. So this is known as point to point control system. And if I talk about what is straight line control system, straight line control system. So here Please remember here, along with the endpoints. So endpoints तो है ही, but along with the endpoints, but whatever the path followed by the tool is also important. Please remember, along with these endpoints, whatever the path followed by the tool is also important. Then that control system is known as straight line control system. Okay, and please remember here there is a simultaneous movement of two axes is necessary or required. Here what, with the endpoints, the path followed by the tool is also important, rather you can say this is the path function, isn't it? This is the path function. And of course here the simultaneous movement of two axes required, simultaneous movement of two axes are required. Example कौन कौन से हो सकते हैं इसमें? और simple milling is there, turning is there, milling, turning, then we are having what, seam welding, isn't it? Okay, so in based upon the control system we are having point to point, we discuss the straight line, and third is what, we are having the contour or continuous. Third is what, the contour, or it is also known as continuous. See here, so no doubt we require the endpoints, the path. Okay, but the path is contour or curved path is there. Okay, it may be like this, or it may be like this. Okay, it may be concave or convex. But see here, the thing is that whenever we are go for having such a kind of shape, isn't it? Theoretically you can see the curve like this, but when you see in the actual, how was the tool movement? In theoretically we can say that we can get the curve, okay, but when making this curve, the movement of the tool is again the straight line only. Please remember, so this is the movement of the tool is in straight line to produce this curve. And we can go towards achieving the smoothness of the curve. When to have the smoothness in the curve? When the distance between two adjacent points, okay, that has traveled by the tool is less. जितना ये tool का जो interpolation है, जो feed है, right, that is distance between the two consecutive or nearest points, जितना कम होगा उतना ये कर्व क्या होगा, स्मूथ होता चला जाएगा, isn't it? So that's why the interpolation for this contour paths we are having from say 0.001 millimeter to 999.9 millimeter. To get the smoothness or smooth curve, what we want, we have to select the very low, very small interpolation. The interpolation is what? The distance between the two nearer points followed by the tool. Okay, so no doubt when you are using this value of interpolation very small, you will get the smooth curve, but time required for making that contour will be maximum. So please remember here, in continuous or contour control system, the path traveled by the tool is not straight, it is in curve, it is in contour. Okay, and here the simultaneous, if we talk about the simultaneous movement of the axis, we should have the simultaneous movement of three axes. Please remember here, the simultaneous movement of 3 axes, that is x, y, z, are required, okay, in contour control system. Okay, so after seeing the classification of NC machine based on the control system, now we are having the next classification based upon the control systems, based upon the feedback system that is used in the NC machine tool. If see, there are two categories in this also, that is, one is open loop system and another is closed loop system. So in open loop system, if there is no feedback system is used in the NC machine, then it is known as the open loop system. And if the feedback system is used in the NC machine tool, it is known as the closed loop system. So let us take this open loop system, and we know how this relation between this work table and stepper motor and lead screw, we know this. So see here, this is the stepper motor connected to the lead screw. On that, this work table is there, work kit is there, and it is having the linear movement of axis, isn't it? Here and here. Okay, so this is the lead screw, this is the lead screw, this is the work head. Now see here, generally in open loop system, the stepper motor is used, which is driven by the series of electrical pulses produced by the machine control units. So see here, for every one single pulse, so this motor is rotated for the fraction of one revolution, isn't it? So for one pulse, the motor is rotating for the fraction of one revolution, isn't it? One revolution. Then what I can write here? Then say this alpha is the angle, step angle in degree per pulse. Alpha is the step angle which is in degree per pulse, which is equal to what? It is 360 divided by ns. Ns is what? So ns is the number of step angles, and it must be the integer, So you will get this alpha, that is the step angle in degree per pulse, which is equal to 360 divided by ns. Now see here, this shaft of the stepper motor is coupled with the lead screw, but many times what is there? There is a use of the gear. There is a use of the gearbox for the to reduce the RPM or the speed of the lead screw. So for the speed reduction, we are using the gearbox. So suppose if there is a gearbox and Rg is the gear ratio. Rg is what? The gear ratio. Now tell me, what is the angle? What is the angle of the shaft of this motor? What is the angle of the shaft of the motor? Or I can have the angle through which the shaft of motor is rotated. So say this is AM, which is equal to what? This is equal to this alpha, that is the step angle in degree per pulse, into NP. NP is what? So NP is the number of pulses received by the motor, where NP is what? The number of pulses received by the motor. Now what I can write here? So I can write here this alpha, you know, so AM is equal to 360 divided by NS into NP, isn't it? And see here, if I want the angle through which the shaft of lead screw is rotated as A, it's given as A, then what is this? A is equal to actually this alpha into NP divided by RG, speed reduction by the gear ratio RG, isn't it? Now see here, what is this RG actually? So RG is this, the gear ratio is given as AM divided by A, or in terms of revolution NM divided by N. This is the RG, isn't it? So here what we want? A. So A is equal to what? AM divided by RG. AM divided by RG. So if I solve here for this, A is equal to AM divided by RG, and we know this. See, we have solved here. A is equal to, AM is what? Alpha into NP divided by RG. Now see here, if say the linear distance traveled by our lead screw, our LS lead screw is equal to what? The pitch into fractional or complete revolution, of motor. We know this, that is pitch into RPM will have the linear displacement or linear distance of this lead screw. So this pitch, if P, so what is fractional or complete revolution of motor? It is nothing but A divided by 360, isn't it? We can write this. A is what? The angle through the angle of the shaft of the lead screw, which the lead screw is rotated, angle through which the shaft of the lead screw is rotated, that is our A, divided by this 360 degrees. You will get the linear distance traveled by the X. Now put here value of A. A is what? So X is equal to P into alpha into NP divided by RG into 360. So please see what I am doing. So X is what? The linear distance traveled by our work table, isn't it? So P is the pitch. P is what? Pitch of this lead screw in mm per revolution. So see here, and we know how to write this alpha. We know alpha कैसे लिख सकते हैं हम? Alpha is nothing but 360 divided by NS, isn't it? So from this equation, if I want to find out the number of pulses received by the motor, how can I write this? NP is equal to, so X into RG into 360 divided by this P into alpha is what? This is alpha, 360 divided by NS, isn't it? So how can 360 get cancelled? So NP is equal to what? This XRG into NS divided by P. XRG into NS divided by P, where X is the linear distance traveled by the lead screw, RG is the gear ratio for the reduction of the speed for the lead screw, into this NS is what? The step angles, it should be integer, divided by this pitch of the lead screw in mm per revolution. You will get the number of pulses received by the motor, isn't it? This is NP. So what will get? NP is equal to NS into X RG divided by P. That is very much correct. So see here, after seeing the classification of NC machine tool based upon the feedback system rather, the second part, the second sub classification, we are having the closed system. So in closed loop system, open loop system just now we have seen. Now we will see this is the second classification in that sub classification rather you can say. So here we are having the comparator, we are having the digital to analog converter, and then here our servo motor. Please remember, in closed this is the comparator, this is the digital to analog converter, and here we are having this servo motor. Okay, and it is connected to what? Our lead screw. And lead screw, at the end of the lead screw we are having here the encoder. This is the encoder, and here we are having this work table, this is the work head, this is work table, it is having the linear movement like this, and this is of course the lead screw, right? So here actually say if this is the input positive, say here this is the feedback signal, this is the feedback. Okay, so here the encoder is placed on the axis, that is on the lead screw, at the end of the lead screw, which will measure the movement of this axis, and encoders we know it can be measured up to the nanometers. So here we have seen that in closed loop system, this displacement measuring devices, that is the encoder here I have shown, so these are measuring the movement of the lead screw and giving it value to the machine control unit, so that machine control unit, what will it do? It will analyze that information, that is it will subtract the actual value from the required value, and remaining value, for that it will produce the required electrical pulses, and by using these pulses the machine, or sorry, the motor is going to produce the required mechanical energy to move the axis for the required distance. So this is how this closed system is, or closed loop system is going to work. So this is the classification we see based on the feedback control system, open loop system, and this is the closed loop system. Open loop system में generally please remember stepper motor use होती है, whereas the closed loop system में servo motors use होती है. And what is speciality of servo motor? We know it is having quick acting or action braking system. It is having the braking system, very high accuracy, positional accuracy we can achieve by using servo motor. Okay, now the third classification that we are going to see is, so in that we are having two-dimensional 2D axis. Okay, two-dimensional. So when, see, in 2D system, when there is simultaneous movement of two axes, okay, and here we have not considered the rotation of the spindle, that is rotation of the job. Okay, so it is known as two-dimensional control system based upon axis. Okay, then we are having, now after 2D we are having 3D control system. So in 3D control system we are having the simultaneous movement of two axes, simultaneous movement of two axes. In addition to that, with third we are having the rotation of the spindle, the rotation of the spindle or job. So this is 3D control system. What is 4D? We are having 4D control system means, so along with this 3D system, that is two axes are having simultaneous movement, we have considered the third axis as the rotation of the spindle or rotation of the job, and at the same time these two tools here, actually two axes, that is the tools, are removing the material also. So here in the same case in 3D control system, if the tool is removing the material, tool is removing the material, it is known as 4D control system. So see here, after 4D we are having the 2.5D control system. So what is here in 2.5D control system? So here actually the programmable movement along all the three axes, that is x, y and z, that is here programmable movement along x, y and z axis. But if you look at the simultaneous movement is only about two axes, only about two axes. This is known as 2.5D control. So this is used, for example, if you take the cylindrical cam, where we use this 2.5D control system. So this is the classification of the numerical control system based upon the control systems, point to point, straight line, contour, then based upon the feedback system, that is open loop, closed loop, and based upon the axis used, we are having 2D, 3D, 4D, 2.5D, we can go up to 11D. So this is the classification of NC machine tool. Thank you.